Hi, I'm Debraj and I'm back with my new creation. It's a two-wire serial interface for controlling a graphics LCD. So as you can see, this is my controller board and it has two wires. So the first question, why does this board has four wires? That's basically there are two wires which are basically the clock and the data, and the other two are the 5 volts and the ground, which by standard we don't count, but there are physically four wires, but for controlling we are using these two wires. So these are the four wires which goes from a controller board to the graphics LCD, and this is my LCD which is working. So this is another view of my LCD working. You can see the bars are changing quite fast, and the numbers even they are changing quite fast. So the serial interface is quite adequate to run the LCD in graphics mode, and just because we have changed from a parallel to a serial interface, it does not mean that the thing has slowed down. And to show you the interface board, so this is the LCD, which is the green color board. You can see this is the LCD. Currently I have removed the power, and this is the interface board which fits nicely behind the LCD board, and these are the four wires, and there is a port for changing the LCD contrast. And this is the interface board which I have removed. I have kept it separate. So you can see the 20-pin header which basically fits like this behind the LCD, and it is made with two 74HC595 IC, and the hardware details and the software code you can find on my website. And the controller that I am using is a microchip DSPIC 28-pin. It's a 3.3 volts IC, but once you use this serial interface, it basically does not matter whether you drive the LCD from a 5 volts or a 3.3 volts. The controller, the pin which controls these two wires, does not have to be always 5 volts. It can be even 3.3 volts, because now you are not interacting directly with the LCD, but with this 74HC595, whose VIH and VILL quite compatible with 3.3 volts as well as 5 volts. So once you use this board, you can use any voltage right from 5 volts to 3.3 volts and even slightly lesser. So just a close-up view of my interface board. So it has basically one and two decoupling capacitor, one a big capacitor that's for the reset circuit, and two resistors. So one is for the reset and the another is for the enable circuit, and there is a diode as well, that's a 1N4148. So as you can see, the hardware is pretty simple. You don't have to program a separate code for this device because it's purely hardware. It's a serial to parallel interface, and the back side of the board is even simpler. So if you want to make a real PCB out of it, like what I have done is basically soldering on a general purpose board. If you make a own PCB, the PCB is going to be very simple, and it will fit behind the LCD. Also, I have made the board design in such a way that this edge and this edge are almost in line. So if you want to fix it onto inside a box, so you don't have to bother about this this interface board going behind this edge and basically fouling with your inside of the box. So it's portable, and your dimensions are exactly same as the LCD. So let me show you. I'll switch off the power and I'll switch it on again, and you can see that there is absolutely no delay whatsoever. So let me switch on the power now. So you see the display coming right at the moment the power is switched on. And if you feel that this interface board is useful by reducing the number of pins that you use from the microcontroller, you can go ahead and use it. And thanks for watching my video. Thanks a lot. Bye.